So now we're looking at page 66, number 18, and it's still explain why you cannot use substitution to determine the limit. All right, so if you substitute in 0, you're going to get 0 over 0, which is undefined. You want to write that as a mathematically complete sentence like this. The limit as x approaches 0 of 4 plus x squared minus 16 over x cannot be determined by substitution because 4 plus 0 squared minus 16 over 0 is equal to 16 minus 16 over 0, which equals 0 over 0, is undefined. All right, so that's a complete sentence. So you should strive mathematically to write complete sentences. You won't always, but it's something you should keep as an ideal. Now, and also, like, this is a model of how I'd like you to write the answers to these questions, number 15 and 17, so that you're not just copying word for word what the book says. You want to sort of put it into your own words as a complete sentence. All right. Now, I want to say more about number 18 because it will lead us into the next section of, 20 through 28. So here's the question I have for you. The limit cannot be determined by substitution, but can the limit be determined some other way? Is this limit just undefined and that's it? The answer is no, it is not undefined, and there is another way to do it, and that it's a good example of what we're doing in the next ones. So I'm just going to show you how we would evaluate limit as x approaches 0. So let's say let's say instead of just saying why can't you do it by substitution, the question said, what is the limit as x approaches 0 of 4 plus x squared minus 16 over x? This would be a standard AP exam question or a question in one of my tests. All right, so here's what you do with this. So you're going to algebraically restructure the limit, sort of simplify it as much as you can. When you do that, it's important to remember that we are keeping it as a limit. So this limit as x approaches 0 has to be written each time. Now I'm going to expand out this binomial 4 plus x squared, and you should know that that equals 16 plus 8x plus x squared. And if you didn't know that that equals that, then go back and see why or send me an email. And then I have this minus 16. All right, and then my denominator is x. And then I'm going to say that equals limit as x approaches 0. So talk about complete sentences again. This is a complete sentence mathematically. This limit equals this limit, all right? Remember that if I don't write anything to the left of the equal sign, that means you took the line here and copied it down. That's implied in all mathematical writing. So now I'm going to say this limit equals this other limit, all right? Keep your sentences complete. Keep everything clear. Don't take pieces off and work them separately. Write out everything as you go. That for some of you, that's going to be a new discipline. For some of you, you've already developed that good habit. All right, now I have limit x approaches 0 of 8x plus x squared over x. Now I'm going to factor the x out of the numerator. And the goal here is to cancel the x's numerator and denominator, just like you're reducing rational expressions in Algebra 2. I mean, that's basically what you're going to do. You're going to reduce the rational expression, just like in Algebra 2. But what we've been talking about all this time is when x equals 0, this expression is not equal to 8 plus x. If I cancel these x's, I can't do that when x equals 0, and that's exactly the point that I'm looking at. So here, what we're going to notice is that in the limit as x approaches 0, x cannot be 0. How do I know that? From the definition, the absolute value of x minus c, our c is 0, is greater than 0. So in other words, in the limit statement, the x is never equal to that limit point. All right? So that means that in this limit statement, the x is in fact not 0. Because the x is not 0 in the limit statement, I can reduce the x's out and say this is 8 plus x. All right? So it's important to note that if I didn't have the limits and I said x times 8 plus x over x equals 8 plus x, and I didn't have the limit statements, these two expressions are equal only when x is not equal to 0. But I'm specifically interested in x equals 0, so I cannot leave those limit statements off. This limit does equal this limit, even though at x equals 0, this expression does not equal this expression, because when x equals 0, this expression is 8, this expression is undefined. They're different. All right? Now, once I've reduced the x's, now I can evaluate by substitution. So previously, you could not Right up here, I cannot evaluate, and none of these can I evaluate the limit by substitution. But now there's no denominator, so I can evaluate the limit by substitution. And as soon as I take the 0 and plug it in for the x, then I have evaluated the limit, therefore it is not a limit anymore, and that's where the limit statement drops. So now I'm going to say that equals 8 plus 0. And then I can say 8 plus 0 is 8. All right, so one of the critical things that, as you're writing this, and remember in the AP exam, you're going to write things and you're going to be evaluated on how you write them. Then I'm also going to have free response questions on my tests, and when you take the WestCon final, assuming they don't cancel that, it's important that to remember that mathematicians are reading your writing. So you have to be consistent with, this is a limit, this is a limit, 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 limit. When does it stop being a limit? When I evaluate the limit by substitution. All right, so in this step, what we did is evaluate the limit by substitution. And that's why at that point it stops being a limit. All right. Now, did I have to necessarily write 8 plus 0 here? I don't have to, but it helps clarify exactly what I'm doing. That I substituted 0 for the x, that's evaluating a limit by substitution. All right, now this is evaluating a limit of a rational expression. That's what this was. This is a rational expression, and this is a limit. So this is how you evaluate the limit of a rational expression, and we're going to see a couple more examples of that going forward. But this is our first sort of major, actual, really mathy thing to do.